All right, so here we want to introduce the chain rule. And what the chain rule is for finding the derivative of a composite function. All right, but here's the thing. In order to properly understand what you're doing and be able to do it well, one of the skills that you need to have is the ability to decompose a composite function. Now, in pre-calc honors, at least when I was teaching it, we would have you work with these and actually take functions out, identify what's the inner function, what's the outer function. Okay? So, for example, here on part A, I have 1 over an x plus 1. I could view that as the inside function is an x plus 1. So I'm going to let u be x plus 1. And then if I wanted to write y in terms of u instead of in terms of x, it would be 1 over u. Okay? That'd be 1 over u. So notice I have decomposed it to the interior function, the x plus 1, and the exterior function, 1 over something. Okay? And I like to use that word something. That kind of helps us identify that interior function as like a block. Okay? So here, y equals sine of 2x. What's the interior function here?
2x.
The 2x. We're taking the sine of something, the sine of 2x. So then if I were rewriting y in terms of u, it would just equal sine of u. Yeah. Okay? And then how about D here? I don't know what happened to C along the way here, but what happened? What's D? Okay?
But it's like squared.
Yeah, we got a tangent squared of x. Okay, the inside is the tangent of x. Good, Paul. Okay? Tangent of x. We are squaring something, right? We're squaring the tangent. So y is simply u squared. Okay? I will tell you that the trig functions are the things that people mess up the most. And that's why we had 2 of these. You got to pay attention to, is u inside the trig function?
No.
Or is the trig function inside something bigger? Okay, that's what you have to figure out. Okay, especially the exponent because of the way we write it. Remember, tangent squared of x is really tangent of x squared. That's another way that we could write it. And if it helps you to write it that way when you're doing these, then by all means rewrite it that way. Okay, it's better to write an extra line and get it right than to guess and get it wrong. Okay. So, how do we do the derivative of these functions? Well, here's our chain rule. We want to get dy dx, okay? So what we are going to do is we're going to take the derivative of y with respect to that inner function u. And then we're going to multiply it by the derivative of the inner function with respect to x. And you can see here, if I cancel things out, I end up with dy dx. Okay? Now another way of seeing this, if you're using the f of g of x notation, you're taking the derivative of f, so f prime, but notice you're leaving the g of x alone inside. You're leaving it just as it is. But then you multiply that result by the derivative of the inside. Okay? Now, just as a reminder before we get into these, I gave you a little summary of all the rules that we've learned so far. There's a lot here. Okay? So keep those in mind as you're doing this chain rule. Okay? So let's try some of these. here we have f of x equals 2x minus 1 quantity squared. So let's go through the whole process here. What does u equal? 2x minus 1. So y equals what?
U squared.
U squared. Okay? So now I want to do dy du, and that equals
U squared over 2x minus 1.
no, dy du. What's the derivative of u squared?
2u.
2u. Okay? And what's
2.
du dx is 2. So if I'm using the chain rule, then dy dx is going to equal dy du times du dx. So dy du is a 2u, du dx is 2, so that's 4u. Now, do we want our answer in terms of u? No. Okay? Don't leave your answer in terms of u. So now we go back. What was u? It's a 2x minus 1. So 4 times 2x minus 1, you're right, is 8x minus 4. And there is our derivative.
Yeah.
Yes?
If we simplified further than that, do you want that?
How would you simplify further?
Well, I just took out 4 and
Oh, you didn't distribute.
Yeah, I
That's okay. At this point, like, it really depends on what you're going to be doing, whether you would want to distribute or just leave it factored out. Because, like, if we're finding zeros to get max and min points,
yeah,
then leaving it factored will make it easier. So,
okay.
yeah, it's fine. What's another way we could have done this one, though?
You could have, you could have brought the 2 to the front, or like the exponent, like do kind of like the power rule, and then, multiply that times the inside times the derivative of the inside.
Yeah.
That makes sense.
Well, and that's exactly what we did.
Yeah.
But he just foiled it.
That's how I would.
I could have foiled it, right? I could have made this a 4x squared minus 4x plus 1. And the derivative of 4x squared minus 4x plus 1 is 8x minus 4. Which is faster?
I don't know.
Either one, right? What if this were 2x minus 1 to the 8th power? Which would be faster?
Chain rule.
This. Okay. So if it's something squared that you can FOIL easily, then take your pick, whatever you want to do. You'll get so comfortable with this, you'll probably do the chain rule in the end. But where it's really useful is for like those binomial expansions that are huge and we don't feel like expanding. So, yes?
So from the dy over du times du over dx, why didn't you like include denominators? Or you're not necessarily plugging into a formula?
Well, they're not really denominators. These are the derivative of y with respect to u, which we found was equal to 2u. And the derivative of u with respect to x, we said equal 2.
Okay, yeah, no.
Okay, that's okay. We're getting used to the notation here too, so. All right. Okay. Eventually, you guys will get so comfortable with this, you won't have to write out the u and all that kind of stuff. But that's eventually, so I'd rather write a little more. Okay? So let's see, with this a here, what are we going to do first?
You rewrite this to the half power.
Yeah, we could do that. 3x squared minus x plus 1 to the 1/2 power. Okay, good. So what's u?
3x squared minus x plus 1.
Okay. U is 3x squared minus x plus 1. So that means du dx
Is 6x minus 1.
6x minus 1. Good. All right. How would we rewrite y in terms of u?
U to the 1/2.
U to the 1/2. Very good. So dy du
1/2 u to the negative 1/2.
Yeah, good. Both you guys are right. 1/2 u to the negative 1/2. Okay? So now dy dx is dy du 1/2 u to the negative 1/2, or we could go ahead and translate that negative exponent, so 1/2 1/2 radical u times du dx times a 6x minus 1. Okay? So we can just make that 6x minus 1 over 2 radical 3x squared minus x plus 1. Okay?
Could you simplify the 6 and the 2?
Can we simplify the 6 and the 2?
Because of subtraction.
Yeah, there's subtraction, so just be careful with that. If it were like 6x minus 4, then we could factor 2 out and reduce it, but... Yes, Corey?
Do we have to rationalize the square root?
You don't have to rationalize the square root. I don't care if you do that or not. Again, if it's a multiple choice problem that you're dealing with, they may have rationalized it for the final answer. So obviously you would need to know how to do it, but I don't care if you do it at this point. Okay? Alright, we saw this one above. Okay, we already identified u is 2x and y is sine of u. So du dx 2 dy du cosine u. So dy dx is what? 2 cosine u, which equals
2 cosine 2x.
there you go. Okay? 2 cosine of 2x.
Can the 2 multiply with the 2 from?
Can this 2 multiply with this 2? No, because this is inside the cosine. Alright? So, you gotta do what's inside the cosine, take the cosine, then you have to multiply by 2. So you can't make it like cosine of 4x. Okay? Now, I want us to try one a little bit. I want to show you one here where I'm not writing out everything. Okay? But we should identify at least. What's the u here?
Tan x.
U is tangent of x, right? So, I have something squared, right? So let's think here, what's the derivative of something squared? 2 times that something, alright? So this is going to be 2 times tangent to the first. But here's the chain rule. I need to multiply by the derivative of that something. Okay? So what's the derivative of the something? The derivative of tangent is secant squared. Okay? So eventually you'll get to the point where you're comfortable enough just to be able to write it down at this point. Like this. Okay? So the derivative of something squared is 2 times the something times the derivative of the something.
I find that way easier than the
Okay?
Well, the y would equal x squared.
Y would equal u squared. dy du would be the 2u, so that's where we get the 2 tangent. And du dx is the secant squared. Someone have their hand up?
I did, but I figured what I was saying.
Okay. Alright, let's run through a couple more of these just to get used to it. Okay? What's the u? 2x minus 1. Du dx? 2. What's y in terms of u?
1 over
1 over u, which since we want to take the derivative.
U to the negative one.
Yeah, u to the negative 1. Okay? So let's go ahead and do this. dy dx is
-1
-1 u to the negative 2 times 2. So a negative 2 over u squared, which is a negative 2 over 2x minus 1 squared. Don't FOIL that out. Just leave it like it is. Now question, how else could we have done this one?
Well, you could have, wait, could you have boiled it?
No, there was nothing to FOIL.
Yeah.
Quotient rule, we could have used quotient rule, and the derivative of the top would have been 0, okay? But this is where I think the chain rule, especially once you get more comfortable with it, is going to prove a lot easier to use than the quotient rule would. Yeah, Nate?
If you were to bring in the up to 2x to the -1, could you use power rule in that scenario, or is that the?
Well, yeah,
Chain rule, so.
we kind of did eventually, 2x minus 1 to the negative 1. So we have something to the negative 1 power, so the derivative of that is going to be negative 1 times the something to the negative 2 times the derivative of the something. What's the derivative of the something? That was the 2.
So then you get -2.
Okay? So you get negative 2 over 2x minus 1 squared. Eventually this is probably how you'll be doing them, rather than writing out all the steps, but till you get the hang of it, it's helpful.
Is there going to be a scenario where you have to do like quotient or product rule before you do the chain rule?
Oh yeah, we did those last
Oh,
time.
yeah.
Yeah.
Those were
Oh yeah. Okay. Well,
So long.
yeah, they're
You're just asking for me.
definitely will.
Okay.
Alright, let's work through E here. Let's try to do this without writing down everything. So dy dx, I have something cubed, right?
2x.
3 times.
So 3 times, well, not
And 3
times.
x squared plus 1 to the second.
Okay, good. So the derivative of something cubed is 3 something squared
What times 2x?
times the derivative of the inside is 2x. So we have 6x times x squared plus 1 quantity squared.
Would you just leave it like
That's
that?
how we usually do
Yes.
it.
Yeah, that's how Miss
That's how Miss
Wyatt
Wyatt
us
taught
last
it. She
year, that's why
didn't
it's-
teach the whole way.
Yeah.
That's why you-
And that's great when you're doing ones like this.
But
She
what
did
we
like
just
you do
did.
the outside derivative and then
Yeah.
the inside derivative.
Yeah.
Isn't that pretty much
And
exactly
that's exactly what we're doing. We're just
Yeah.
showing more work, and the more work will become helpful as problems get more and more complex. Because what we'll eventually be doing is we'll have functions inside of functions inside of functions. So you'll have to do the chain rule inside the chain rule.
Isn't that pretty much just the definition of the derivative, almost what you did, or without the x kind of?
Mm,
No, it's like you do
I don't know.
power rule and then you do another inside power rule. Kind of.
kinda, yeah. Okay. Alright, one more here. I would want to rewrite this as a negative 7 times 2x minus 3 to the negative 2 first.
14.
Okay. So negative 2 times negative 7 is 14. 2x minus 3 to the negative third times 2, the derivative of the inside.
So you get
28 over 2x minus 3 cubed. Alright? Do some practice tonight. We'll see you tomorrow. Alright, so let's work our way down. Let's work our way down the first column here. We'll do a couple of these. And I want to point out something along with D, E, and F. We won't do all 3 of those but in a row, but I want to point something out with those. Okay. So, A. Let's look at A. If I'm doing A here, how would I find the derivative of this? What is that? Yeah, it's a quotient, so I've got to use the quotient rule. And the challenge here is that, you know, when I do the derivative of the top, that's easy because the derivative of the top is just 1. But the challenge is when I am doing the derivative of the bottom, okay? Because the bottom we could rewrite as an x squared plus 4 to the 1/3 power. And what am I going to need to use to find the derivative of that? The chain rule, okay? So I'm going to go through all the steps here just to remind us of how to do this chain rule. We identify that inner function, u, which in this case is x squared plus 4. And then we rewrite this whole thing in terms of the u. So that's going to be u to the 1/3 power. Okay? Now, the chain rule says, remember that dy dx is dy du times du dx. Okay? So, if I take the derivative of u, this is going to give me the du dx, which is just a 2x. And if I take the derivative here, this is going to be my dy du. Okay, I'm taking the derivative with respect to u now, and that's simply a 1/3 u to the negative 2/3. Okay?
Should we leave it like that rather than bring it down?
I'd leave it like that, at least initially, and you'll see why in a sec when we go to actually do the quotient rule, okay? So at this point, really, we're just trying to get the derivatives that we need to then use in the quotient rule, all right? So we do dy du, which is a 1/3 u to the negative 2/3 times du dx, which is a 2x. And at this point, before we put it into the quotient rule, we should go ahead and plug u back in. All right, so I'm going to rewrite this as 2x over 3 times the u is an x squared plus 4, and that's to the negative 2/3 power. Okay? So now I have the derivative of the top, I have the derivative of the bottom. Had to go through a lot of work to get there, but I have the derivative of the bottom now, and now I can use the quotient rule. Okay? So, f prime is derivative of the top times the bottom, so x squared plus 4 to the 1/3, minus f times the derivative of the bottom, so that 2x over 3 times x squared plus 4 to the negative 2/3 power, and that whole thing is then over, what do I get when I square the bottom?
To the 2/3.
Yeah, if I have this to the 1/3 power and I square it, you multiply the exponent, so 1/3 times 2 is now 2/3. Okay? Is everyone with me so far?
Yes.
Alright, so this, if all I had to do was get this so that I could then plug something in, I would just stop here and plug it in. Okay? However, if the goal is to actually find the derivative like it is here and express it in a way that's simplified, I would want to keep going. And the reason I want to keep going is because I have that negative exponent in the numerator. Okay? So this is how you're going to handle this every time. And by the way, this does this every time you have the chain rule inside the quotient rule or the product rule. Okay? What you're going to do here is you're going to identify that common factor and the lower exponent, okay? So here we have the negative 2/3 power. I'm going to pull out that, oh, let me get back to pen. the x squared plus 4 to the negative 2/3 power. The reason why I'm doing this is because if I factor it out, then I can take it down to the denominator. Okay? The challenge here is, I know since I took the whole thing out, I have a 2x squared over 3 as the second part of this. But what do I get when I factor a negative 2/3 power out of something that's to the 1/3 power? Okay? That's the part that people kind of get confused on a little bit. But here's the key. Remember, think about distributing it back in. What power would I have to have here in order to, when I distribute this back in, I add the exponents and get a third? What would this have to be? 1. Yeah. It'd have to be 1, because negative 2/3 plus the 1 would give me the 1/3. Okay? And the reason why this is confusing is because your exponent gets bigger after you factor something out. But it's doing that because you're factoring out a negative exponent. Okay? So be careful with that. Once you get the hang of it, it's not really hard. But now, since I factored that out, I can pull that down to the denominator, pull this down here, and now I can put these together. So x squared plus 4 to the 2/3 down here times another x squared plus 4 to the 2/3 means that my denominator will be x squared plus 4 to the 4/3.
Could you not just simplify that?
Into what?
Like, since they have this, or would that not be considered the same exponent but negative? Because if it's a negative exponent, it's just completely different.
Well, if it's a negative exponent, but then I bring it down here, it's positive then.
No, but I mean, like, could you just cross them out because it's a negative and a positive, or no, because it doesn't work that way? with
Yeah, you
exponents?
can't
Okay.
cancel it out if they're opposites. Okay?
Where did the x go, like, from the numerator?
Here?
Yeah, where did
I
that
just
go?
put it together there, that's why this is
Oh.
squared now.
Okay, yeah, I see.
Okay? And now in these brackets I have an x squared minus a 2/3 x squared. So this is going to be a 1/3 x squared plus 4. Okay? If you really hate having the third in there, just factor it out and you'll have an x squared plus 12. And you can bring that 3 down to the bottom. Okay? I don't really mind if you leave numerical fractions up there, but don't leave negative exponents and all that kind of stuff up there.
So could you have left it as
Okay.
x squared plus 4 minus 2x squared over 3, or no? Because
No, you should at least put the like terms together. But I don't care if you leave an x squared over 3.
For the g of x squared at the very beginning,
Mhm.
what happened? Why did you not incorporate the 2x over 3 in it? Because isn't that part of the g prime x? Or, yeah, g of
Well,
x squared, whatever.
G of x was just this to the 1/3 power.
Okay.
So when you square something to the 1/3 power, it becomes the 2/3 power.
Oh, it's not g prime.
No, it's not g prime squared, it's just g squared
Okay.
on the bottom. All right, now I'm gonna skip B for now. I want to look at C, D, E, and F. These are all very similar. Okay? But you gotta be careful to you've got to be careful to make sure that you're paying attention to your order of operations here. Okay? So for example, if I see part C here, I see cosine of 3x squared, I'm going to see that as parentheses around the 3x squared. That whole thing is inside the cosine. So I'm going to do, the outer function would be cosine, the inner function would be the 3x squared. okay? So let's actually do this one. F prime of x. If the outer function is cosine, what's the derivative of cosine? It's negative sine. So our derivative would be negative sine, and notice the 3x squared just stays the same.
You don't do anything.
But now we multiply by
Now I have to do
the derivative of the inside. Okay? So the derivative of the inside is 6x.
Oh, so you just skipped the step going from the negative sign to u, making that negative sign 3x squared.
This is dy du, and this is du dx. Okay? Now, I would probably rewrite it just to avoid any confusion and make that a negative 6x sine of 3x squared. Okay? But, notice how this is very different than d. What's the cosine of 3?
That's bigger.
That's just a constant.
Yeah, it's just a constant, right? So when you're taking the derivative of something multiplied by a constant,
It's just
so then
2x.
f prime x is
Yeah.
0 because when you multiply 2x it's still going to be 0.
well, no, that would be if you're adding a constant, the derivative of that constant is 0. When it's multiplied by a constant, you just take cosine of 3 and you multiply it by the derivative, which would be 2x. Okay? So this is just 2x. I would rewrite this as 2x times the cosine of 3, just to avoid confusion. Okay? But notice the difference the parentheses makes. One, we have to use a chain rule. One, we just have a constant we're dealing with. Okay?
So if it's a constant multiplied by something else, it just stays.
Yeah. I mean, this is no different than if we had 4x squared. You would do 4 times 2 is 8, x to the first,
And you
right?
don't have to do product rules or anything?
Nope. You could, but hey, guys, here's a good question. Could we do product rule here? Yes. But check this out. If I do product rule, what's the derivative of the first factor? That's 0. So my f prime g is just going to end up being 0. So I have plus f g prime, that's cosine of 3 times 2x. Okay? That's why, yeah, if you're not sure, go ahead and do it. And you might get a 0 and then realize, oh, I guess I didn't have to. But better to be safe than sorry. Okay? Now then we have the cosine of 3x quantity squared. Okay? So really what we have here is we have a double chain rule. Because the 3x is being squared, and that whole thing is inside the cosine, right? So, you have a couple of options. We could just simplify 3x quantity squared.
Would that be 9x?
Yeah, we could rewrite this as cosine of 9x squared, and probably that's what I would do. Okay? So there's f, so now f prime, what's the outer function here? Cosine, so the derivative of cosine is negative sine, and it's the negative sine of what? 9x squared. Okay, when you do the derivative of the outside, the inside stays intact. Then times 18x, the derivative of the inside. Okay? So negative 18x sine of 9x squared.
Can you simplify that any further, or you just leave it like that?
Can we simplify this any further, guys?
No.
No. No, that's as good as we can get. So back here on B, we have 3x minus 1 over x squared plus 3. What do we have to use to find the derivative? Quotient rule, okay. So, what's the derivative of the top? 3.
Times.
The derivative of the bottom is 2x. So, f prime of x is the derivative of the top times the bottom
Over.
minus the top 3x minus 1 times the derivative of the bottom all over bottom squared. Okay? So, simplify a little bit, see what we can come up with. 3x squared plus 9 minus 6x squared plus 2x. Do not FOIL the bottom. Leave it alone.
That's negative 3x squared plus 2x plus 9 over x squared plus 3 2 squared.
Correct. Okay? So, not too bad. Just a basic quotient rule. Didn't have to do chain rule here at all. Okay? Let's skip down. F and G, I want you to notice the similarity here. F and G both. What is the outer function? What's the inner function? For F, what's the outer function on cosine squared x?
Just x.
Cosine
No,
2.
cosine x. No? You just
That's the
cosine
inside.
What's the outer function?
Cosine square x.
The squared. Okay? Again, if you guys are having trouble figuring out what's inside and what's outside, think about evaluating. If I said find cosine squared of pi over 6, you'd have to find the cosine of pi over 6 first. That's the inside function, cosine.
Right.
Then you would square that result. That's the outer function. Okay?
You can do product rule as well.
You could make it cosine times cosine and do product rule. That would work too. It would be longer.
Okay.
Because here the quotient or the chain rule, if the outer function is something squared, what's the derivative of something squared? 2 times something, yeah. 2 times something. But then I've got to multiply by the derivative of that something. What's the derivative of cosine? Minus sine. Okay? So I'm multiplying by negative sine. So this is a negative 2 sine x cosine x. Okay? If you really wanted to get fancy, you could make it a negative sine of 2x with your double angle formula. But you don't have to. Okay? That's our chain rule. So, if I rewrite it like this, okay, remember our whole u process? U would be the cosine of x. Y, rewritten in terms of u, would be u squared. Okay? So the dy du would be a 2u, or 2 cosine. And then the du dx would be the derivative of cosine. That's our negative sine. Okay? If you're ever confused, go back to that process that we learned at the beginning. That's why we learned that. Write down what u is, rewrite y in terms of u, and then do your dy du and du dx. Okay? Now, G is very, very similar. Okay? What's the outer function here? Something to the 1/2 power. Yeah, so that y is going to be u to the 1/2 power. The u is cosine x. Yeah. So if I'm finding f prime of x, we will have a negative sign in there. That's the derivative of the inside.
1/2 times cosine. times negative sine x.
Yeah, there you go. The derivative of the outside is 1/2 cosine to the negative 1/2. The derivative of the inside is the negative sine. If I want to simplify that, I'd make it a negative sine x over 2 radical cosine x. Okay? All right, so H. H is an interesting one. All right, we have f of theta is 1/4 sine squared of 2 theta.
Is it times 2 theta, right?
No,
Would be
it's sine squared of 2 theta. You can't just have a sine squared. It's a function, so it's got to take something. Okay? So, the 1/4 is just there, right? So f prime of theta is going to be 1/4 times whatever we get for the rest of this. So let's just write that down and not worry about it. Okay? So now we have sine squared of 2 theta. How many different functions do we have involved here? 3. We have,
No, why 3?
we have a something squared. We have sine of something else. And then what is that something else?
Double
2 theta. Okay? So that's the u. Alright? I know this is not like formal notation here at all, but it helps us to put it in terms of words. Okay? Guys? So, if I need to do the derivative, I need to use the chain rule twice. Okay? So let's start at the outermost function. The outermost thing is what?
2 theta.
The square. Just the square. Okay? So the derivative of something squared is 2 times that something to the first power. Okay? Now I have to take the derivative of that first something. Okay? So how do I take the derivative of sine?
cosine.
Well, that's cosine. So it's cosine, and the 2 theta stays put. So now I've taken care of that, but then I have to multiply by the derivative of that innermost thing, which is 2. Okay?
I'm not following.
How do you get cosine again though?
Yeah, I don't know.
Oh, because that's a derivative
Because
of
the
sine.
derivative of
All right.
sine 2 theta.
So follow it here, guys. Follow me here. I take the derivative of the square, so it's 2 times this to the first,
Yes.
times the derivative of the sine, which is cosine,
Okay.
times the derivative of the inside of that, the 2 theta, which is 2.
So you're going to use the chain rule until you have a constant.
We're using the chain rule, and then as we're doing the derivative of the inside, we realize we need to use the chain rule to find the derivative of the inside. Okay? Because the inside initially is sine of 2 theta. And it has something inside of it, you know? So it's a chain inside of a chain. So then we go to simplify, and the 2 times 1/4 is all just 1.
Sine 2 theta times cosine 2 theta.
Correct. Okay? Sine 2 theta times cosine 2 theta.